Hi class, this is Dylan Blair. In this video we are going to be going over those two examples for 7.1 through 7.3 story problems. So this is 7.1 through 7.3 story problems. Okay. Examples. I decided to make the videos for any example videos to be a black background so that it's easy for you guys to kind of see which is lecture versus which are examples. But either way, just a slight subtle tidbit that I decided to do. So for the first example, we had a mountain road with a 7.5% grade. You see a tall tree standing perfectly perpendicular along the road. Then, from a point 520 feet downhill from the tree, the angle of inclination from the road to top of tree is 5.8 degrees. What is the height? Okay. So this is assuming that you watched the other lecture video to have learned about the terminology. But the terminology that we're testing here, that I'm showing you here, is that grade aspect, okay? And also to kind of think about like what is actually being said here, okay? So, let's see. So we have a tree, very beautiful picture of a tree, and we have a road that's at some angle. And here we are, and we want to know what is the height of this tree. Okay. Let's see. This angle right here, because this is the road, right? Here's our road. This angle right here is going to be that angle of inclination. So that's going to be that 5.8 degrees. Okay. Well, now this angle right here, this ends up being that grade. I'm going to label this alpha, okay? Because we actually don't know what this angle is yet until we actually solve for it. And how we can solve for alpha is we can say tangent of alpha is equal to 7.5%, which is equal to 0.075 in decimal form. And then alpha is going to be equal to tangent inverse of that grade. And if you were to plug this into your calculator, you end up getting 4.3 degrees, which is as expected because tangent inverse has a range of negative pi halves to pi halves, and we know that that grade can't be well, it can be a negative grade, but it can't exceed 90 degrees, right? We got this 4.3 degrees. If we had a negative grade, we'd have a negative angle. We'd be going downwards. So maybe in a different story problem, maybe we are up here and the tree is down here, and the grade maybe was negative 7.5%. But either way, let's continue on. So, a new thing that we are going to be able to have is we're going to be able to solve for this entire angle right here, right? Because right now we're looking at an oblique triangle, which is what we want, right? We're in chapter 7 and that's what we are studying in this chapter is oblique triangles, okay? And we know that we have this right triangle with this additional grade to it. So let's call this main angle that we want beta. We can say beta is going to be equal to 90 degrees plus alpha. And so that's going to be equal to 94.3 degrees. Okay. So now we have basically everything that we need to know, right? In order to solve for this, we have two angles and we have what was it? We had from a point downhill the road. So this was 520 feet. Right. And since we have two angles, we should be able to solve for this last angle right here. Let's call this gamma. And we can say this gamma is equal to 180 degrees minus 5.8 degrees minus 94.3 degrees. And if you were to plug that into your calculators, or if you guys are very good at subtracting and adding decimals, it takes me a minute to do it in my head. So I'm going to cheat. And it ends up being 79.9 degrees. Okay. So then what we can do is we can use law of sines because we want to know what this height is. So that means that we have this pair. We have this pair for this 5.8 degrees to this height. And we have this pair for this 520 degrees to this gamma. Okay. So we can say using law of sines, we have h over sine of 5.8 degrees is equal to 520 feet. Make sure you don't leave off the units, right? Because we're looking for the height of the tree. We don't want to say, oh, it's 20. Great, 20 what? It's 20 feet, okay? And 20 was a arbitrary number that I threw out. I don't think that the answer is 20. But either way, small little tangent that I went off on. Sine of 79.9 degrees is in the denominator to complete our law of sines. And then we want to manipulate this so that we can solve for h. So the h ends up being sine of 5.8 degrees over sine 79.9 degrees multiplied by 520 feet. For an exam or something, we don't know how to evaluate sine of 5.8 or sine of 79.9 without a calculator. It might change a little bit now in our scenario, but I will keep you guys updated on that, whether or not we will allow calculators or not. Not like a way that we can enforce it anyway. But either way, if you were to plug it into a calculator, especially for the purpose of the homework, this will be 53.38 feet if we are rounding to the nearest second decimal place, or the nearest hundredth. Okay? And that is the height of this tree from this problem statement. Okay? Okay, let's now, I don't know why I did everything in blue, looks kind of weird. Let's move it to gray. Let's now do the second example. We have a campfire bearing north 40 degrees east from yourself. Okay? You have a friend who is 3,400 feet due east from you. And they are bearing the fire north 21 degrees west. Okay, let's add this from them. Okay, what we want to know is what is the distance from this campfire to you, and what about the distance from the campfire to your friend? Okay, so there is our problem statement. Now let's set up our problem. Okay, so let's leave that up there. Let's see. Let's say we have this nice little fire. Okay, and let's say you are down here. Let's say your friend is over here. And the only reason that I know this is just from kind of pre-guessing these. It's not always the case that you can just kind of draw these out, but either way, we can show that that is yours and your friend's position to the campfire, because we are north bearing 40 degrees east to the campfire, and your friend is north bearing, it's actually, yeah, let's move the friend a little bit. Say the friend is right there. Let's adjust his position a little bit, because we know that he is directly east of you, right? Because this way is east. Let's move these guys over. Yep, and that looks like a much smaller angle. So 21 degrees west from the north position. Okay. Now what else do we know? We know the friend is 3,400 feet due east from you. So we know that that length from you is 3,400 feet. And what else do we know? We don't know anything else. Okay, great. So let's start solving this. Now this is a oblique triangle because there's no right triangle here, but we don't know what this angle is. We don't know what this angle is yet, and we don't know what this angle is. Okay, so let's call this alpha. Let's call this beta. Let's call this gamma. Okay. Well, alpha we can solve because we know that this formulates a right triangle, and beta we can solve because we know that this formulates a right triangle, even though that looks like an awful right triangle. Okay. So we can say alpha is going to be equal to 90 degrees minus 40 degrees, which is equal to 50 degrees. beta is going to be 90 degrees minus 21 degrees, which is 69 degrees. Let me double check my notes, make sure I don't say that wrong. Okay, good. And then gamma, now that we know these two angles on the inside, we can then solve this gamma. I really don't like how I drew. I'm very picky, if you guys haven't noticed this yet. I drew that right triangle. This looks funny. Okay, now back on track. We know that the sum of these angles has to be 180 degrees, so we can solve for this gamma. So we can say 180 degrees minus alpha minus beta is going to give us gamma. And that ends up being 61 degrees when you perform the calculation. Okay, now what we want to know is we want to know this B. Let's actually change colors. We want to know this B. We want to know this A. Right? We want to know the distance to the fire from yourself as well as the distance to the fire from your friend. Okay. Well, this ends up being a law of sines problem again, and it doesn't really matter that I did two examples of law of sines. The purpose of doing these examples is just helping you guys see how you can formulate these story problems. But either way, we know gamma and we know this length, and we're looking for A and B, so we can set both of those up. I'm not going to actually solve them, I'm just going to help you guys set them up, because we know that A is what we're looking for. A over sine of 50 degrees is equal to 3,400 feet over sine of 61 degrees. And then we solve for A. And then we also know B over sine of beta, which is 69 degrees, is also equal to 3,400 feet over sine of 61 degrees. And then we can then solve for B. And then we're done. Okay, we've solved for the distance from you and your friend from the fire. Okay, and yeah, that is it for these examples. If there's further questions, we have office hours Wednesday morning, so be sure to join the office hours. Thanks, guys.